So section 4.4, part 2, longest section ever, is on derivatives of exponential and logarithmic functions. So we talked about a couple of these already. Okay, so in Algebra 2 and pre-calc, you learn the law of exponents. So if I have a to the x times a to the y, it's a to the x plus y. You add the exponents. The next one is a to the x minus y. A to the x quantity raised to the y is a to the x times y. And then a times b, all raised to the x, is a to the x, b to the x. Look at the graph of e to the x. Notice how at the bottom the slope is almost 0, and then it gets slightly steeper, 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 and then it gets very steep. See how the slope's working? So the slopes of the tangent lines. The slope of each, so at x equals 0, see how that's the point 0, 1? The slope at 0, 1 is 1. The slope at 1, comma, e to the 1 is e to the 1. All right, the slope at each point is whatever the y value is. So in other words, e to the x is the only function that has, that is its own derivative. The derivative of e to the x is itself e to the x. Easiest one in calculus. All right, so number 1, differentiate the function. Did we already do part A? Okay, so we already did A. Let's do B. So if I have g prime of x, I'm going to have to use my quotient rule. So low derivative of high minus high derivative of low all over the square of what's below. Okay, notice how when you took the derivative of the high, so e to the x, and you just had high, e to the x, that means you have an e to the x in common that you can pull out. And this will happen every single time. You'll always have that e to the x or e to the 2x or whatever it was. So we pull it out to the front. When I do that, I have 1 plus x minus 1 left. So I get e to the x times x, so we write it as x e to the x all over 1 plus x squared. And that's your answer. Okay, next up. This is a chain within chain. So chain within a chain. Okay, so I have y equals the square root, so I'm going to have parentheses 1 plus 3e to the 2x inside of it, and it's going to be raised to the 1/2 power because I have the square root. That's a 2x. 3e to the 2x. All right, now in the last class, Catherine was asking me about one of your homework problems, which looked like, I don't know, like this, I think. Y equals e to the negative x over 4. She was like, how do you take the derivative of that? I know how to do e to the x, but I don't know how to do e to the negative x over 4. All you do is you just write the exact same thing, e to the negative x over 4, and then multiply by the derivative of the power. So what's the derivative of negative x over 4? Negative 1/4, right? Because isn't negative x over 4 just negative 1/4 x? So it's just negative 1/4. All right, that's the chain rule. So you think of it as being e to some other variable, u, and then you tack on derivative of u. Just like implicit differentiation, you tacked on the dy over dx. Same kind of thing. All right, now the big thing that people have trouble with at first is they think of the power rule. They're like, I have a power. So I'm going to multiply, or I'm going to bring this negative x over 4 to the front, and then I'm going to subtract 1 from the power.
No.
You cannot do that. Why can you not do that with this one?
E doesn't work that way.
E doesn't work that way, but more specifically, it's the power that's...
X isn't constant.
X isn't just a number, right? It's a variable. So if you have x as a power, you cannot do that for any time. So if x is your exponent, you cannot do that rule. You can only do it for constants. Okay, so in this example, so if I have y prime, I'm going to pull the 1/2 to the front. I'm going to have the same thing that was on the inside again, raised to the negative 1/2, but then I have to multiply by the derivative of what was inside. So the derivative of what was inside is derivative of 1 is 0 plus 3e to the 2x times the derivative of that power, so you're going to have times 2. Does that make sense? It was 2 chains.
9y.
So when I do that, I get 1/2. What were you saying? You lost? Are you lost? Are you lost, Tark?
No, I'm good.
Okay.
Where's this equal?
Oh,
So 1/2 and 2 cancel. So I get 3e to the 2x all over. Since this is a negative power, it's on the bottom, and it's a square root. So 1 plus 3e to the 2x. That's your answer. Okay. This next one, part D, has 3 chains. Can you see the 3 chains? Last class had the song Chain, Chain, Chain. You know what I'm talking about? It's not really a song. All right, so y equals sine squared e to the cosine t. All right, so let's see what the chains are. So I have, in parentheses first, I have sine of parentheses e to the cosine t, and then all of that's being squared. So I have something raised to the second power. So if I'm taking the derivative, I do 2 of that something raised to the first power. So that something was sine e to the cosine t. What do I multiply by? You multiply by cosine of e to the cosine t, because that's the derivative of what's inside, times
E to the cosine t.
Wait, doesn't the 2 go away?
The negative sine t.
doesn't the 2 go away?
No, negative sine.
That's a 1. I didn't want it to look like a prime. All right, so times, I heard someone say e to the cosine t times
How about just negative?
negative sine.
Wait, who goes down? 4?
3 chains.
Wait, is it negative sine t or just negative sine?
Negative sine t.
Negative sine of t, yeah. All right, so we had our inside part originally. So I took the derivative of that and got cosine e to the cosine t. But then it has an inside part. So the derivative of that inside part is e to the cosine t times that power, which is negative sine of t.
So
Woo,
we
3 chains.
just leave it back.
Yeah, the only thing I would do is maybe like cross out that negative and put it out front or something, just because it's weird to kind of have a negative in the middle. All right, number 2. So the motion of a spring is described by f of t equals e to the negative 2t sine of 3t. Computes the velocity at time t, graph the velocity function. All right, so this is our position. So the motion is described by this position function. So my velocity is going to be f prime. So I need to take the derivative of e to the negative 2t sine of t.
Oh.
Okay. So I'm going to have to not only use the chain rule, I'm also going to have to use the product rule. So I have 2 pieces. So I have first times the derivative of the second piece, so derivative of sine of t is cosine of t, plus derivative of first, so e to the negative 2t times negative 2 times the second piece normal, sine t. On these ones, remember it's nice to pull out the e to the negative 2t. When you do that, you have cosine of t minus 2 sine of t left. Yeah, I was wondering, didn't I have a 3 before?
Yeah,
Okay. Thanks. Okay, sine of 3t. So I was like, this looks different than the first class. What did I do wrong? Okay, so we have sine of 3t here, and then 3 cosine of 3t. Sorry about that. So Jimmy gets a point. Okay, so then we have 3 cosine of 3t. So I have,
It's a chain rule. You keep the cosine, keep the 3 inside the cosine. No, it's the normal 3 No, it's 3 cosine.
okay, look back at it, guys. It's not hard. I just left off my 3 in the original problem. So the derivative of sine of 3t is cosine of 3t times 3. That's what's here. 3 cosine 3t. Okay, we're finding when it's equal to 0. So it says when is the velocity equal to 0? Okay, so go ahead and get out your calculators. We're going to graph it. Doesn't like it. I don't like what I'm putting into Grapher. Do you guys have it?
Yeah. This is what on my end,
Okay. It should look kind of crazy.
like this.
I don't know. Let's see. I thought it went up and down, up and down. Did you zoom in?
I'm solving on the break.
What?
Okay, find where it intersects the x-axis. So find the zeros.
They're like 4.
I think in the first class I had it like oscillating up and down on the left side.
It is.
Like it goes, doo-doo-doo-doo, and then it goes something like that. I don't know.
Is it 0.328 and 1.375?
Well, I have my windows different.
Yeah, that's what I had.
There we go.
Yeah, this is what.
Okay, make sure you're in radian mode. That's what it is.
Is it like
Radian
this?
mode.
This is what-
So if you guys are in physics, make sure you're changing it back to radian or calculus.
Stop doing it.
Okay.
If you press
We gotta
on
put
and
it
enter, it will
parentheses
stop.
around the negative 2x.
If you press on enter, it will just stop.
Really?
Yeah.
I did not know that.
Yeah, make sure you put parentheses around the negative 2x, guys.
I am in radiant. What is this madness?
Crap.
Yeah, that's right.
Oh, it is?
Okay, you just want to find the first two places where it crosses.
Scott, 0.328 and 1.375.
So I think it comes down and then it goes back up or something. So find these places here. Okay, anybody have them?
I got 0.328 and 1.375 when I solved.
0.328 and 1 point.
When I solved algebraically. That's what I got.
Okay, did you guys get those numbers? 0.328 and 1.375. Okay, you can actually find this algebraically. It involves inverse tangent, like you have to solve a tangent equation. You can find them. All right, Rachel, you get the same thing?
Yeah.
Okay. Now be careful when you're actually finding these on your calculator. Make sure you're storing them. We talked about that before. So you can go back to your normal screen after you find one of them and hit X, and that number that you found will pop up for X, and you can store it as like A or B or whatever. Because notice in the second part of this problem it says, what is the position of the spring when the velocity is 0? So it's telling you to plug those numbers into your position function. So you want to be as precise as possible, because these 3 decimal places that you just found aren't going to give you 3 decimal places in the end. So you want as many decimals as possible for your final answer. Make sense? So you would actually have to store these. Okay, but then you go back and you actually find the position for those 2 values. And the easiest way to do that is plug this in for either y1 or y2. I think you've already done y1 for the other one. And then put them into the table. I don't remember what those exact values are, but you guys understand how to do that, right? So you just plug back into your original position function. All right, number 3, so find the absolute maximum value of the function f of x equals x e to the negative x. All right, so absolute maximum. Absolute maximum means the greatest maximum of all, so the highest point of all. Okay, so we're going to find that by finding when the derivative is equal to 0 first. Because at a peak or valley, the derivative is going to be equal to 0. The slope is equal to 0. So we're going to find f prime of x. Notice I have to use the product rule. Here are my two pieces. So I have x in parentheses, and I have e to the negative x in parentheses. So I have first times derivative of second. What's the derivative of e to the negative x? E to the negative x times negative 1, right? Or negative e to the negative x, right? Plus, derivative of first is 1 e to the negative x. So I pull out an e to the negative x, and I'm left with negative x plus 1. Okay, I want to find when this is equal to 0. But this first part, this e to the negative x, is never equal to 0. I mean, think about it. E is a number. It's like 2.718. So think of a number. If I had 5 to some power, how's that going to equal 0? It doesn't. You can't raise it to anything. You could do the limit as x goes to infinity or negative infinity, I guess, and find it, but no. Okay, so it's never going to equal 0. So that means that this part is not what's making it 0. Never equals 0. So this is the part that makes it 0. So I have negative x plus 1 equals 0, so that means x is 1. Okay, but is that a maximum or is it a minimum? We have some kind of curve. Is that a highest point or a lowest point? We don't really know. So what you need to do is decide if your derivative, so if your slope is positive and then negative, or if it's negative and then positive. Do you guys see what I mean by that? If the slope's positive, so you're going upwards and then you're going downwards, it's maximum. If it was negative and then positive, that means you were going down and then all of a sudden you went back up, so that would be a minimum. Okay, so we do this little sign chart thing. So we do my sign chart, I put 1 on there. I'm testing things in f prime. Do you remember this from Algebra 2? We did critical values. These are critical values. So I want to test a number on the left of 1, so test 0. Test it into the derivative. If I test 0, I get e to the negative 0 times 0 plus 1. So e to the negative 0, so e to the 0 is 1 times 1. So it's positive. All we're worried about is that it's positive, and that tells us that my original function is increasing. Okay, now plug in 2. If I try 2, I have e to the negative 2 times negative 2 plus 1. So I get negative e to the negative 2. E to the negative 2 is positive, but then I have that negative up front. So it's negative. So that means my original function is decreasing. So do I have a maximum or a minimum? Maximum. I have a highest point. Oops, thought I was on the eraser. All right, so you actually need to find how high it goes. So whenever it says find the maximum or the minimum, you need to find how high or low it goes. So we plug back into the original. So I plug in 1. I have 1 e to the negative 1, so it's 1 over e. That's the height. That's the y value, right? So we say max of 1 over e at x equals 1. So that's how we write our solution. Okay. We are going to do a ton of these in calculus. Okay. They are always on your free response questions. Like I will always say, justify that there's a max or min at this location or something like that. Here's what's important. The little sign chart that I just did, everyone does it, but they think that not everybody does it. I've always seen this in any calculus class. We always do these. Okay, but you cannot just do the sign chart on your AP test. You actually have to describe what you did. So you need to say f prime is positive from negative infinity to 1. F prime is negative from 1 to infinity. Therefore, there is a maximum at 1. Does that make sense? You can say it that way. So you can say, this is important, guys. Burke, Isabel, you guys with me? All right, so you can say, all right, so you can say f prime is positive and f prime is negative. You cannot say f is positive, f is negative. Do you see the difference? Because you're talking about the slope when you talk about f prime. You can say f is increasing and f is decreasing. So the original function f, but you cannot say f prime is increasing, f prime is decreasing. So if you're going to say it right, stick with one of them. So you can either say f prime is positive, f prime is negative, or say f is increasing, f is decreasing. That's very, very important. You'll miss lots of points on your career response.
I was
for saying
gonna practice spreading that
Mhm.
multiple ways too.
Oh yeah, every time you take your take-home test, I'll grade you on it.
Oh, yeah.
All right, so anyway, suppose we have the function y equals natural log of x. So in exponential form, this equation is, so remember if I have natural log of x, that's y equals log base e of x. So how do I switch it to exponential form?
E to the y equals x.
It's e to the y equals x, right? All right, so if I have e to the y equals x, let's differentiate both sides. So I'm going to do d dx e to the y equals d dx x. Remember, I'm taking the derivative with respect to x, so if I'm taking the derivative of something with y, what do I need? Yeah, so the derivative of e to the y is e to the y times dy over dx equals 1. So if I'm trying to solve for dy over dx, I get 1 over e to the y equals dy over dx. But y was equal to natural log of x in the original. So that means dy over dx is 1 over e to the natural log of x, which is 1 over x. E to natural log cancels. All right, we've just shown that the derivative of y equals natural log of x is 1 over x. Okay, so that's the next theorem that you guys have. Okay, that one's really important. Don't freak out, you're all right. All right, so we still need to do a lot of examples on those. We're a little bit behind the other class, so. All right, so reminders, your homework is due on Wednesday. Your take home is due on Friday.